All right, today we're going a bit beyond, the standard smoke alarm you have at home. We're doing a deep dive into a very specific piece of equipment, the NTI E-CMD-P carbon monoxide detector.
Hmm.
And the first thing that just jumps out is the price tag. It's listed at $315.
Right, which immediately tells you this isn't for your average living room.
Exactly. So our mission here is to figure out what in the technical specs really justifies that cost.
Yeah.
What's the core intelligence?
Well, what we're looking at is continuous air monitoring at a professional standard. This goes way beyond simple presence detection. This source lets us see how that standard translates into time-sensitive alerts. I mean, the device is measuring a toxic dose over time.
Okay, let's unpack this. We've got the ECMDP, and one of the first surprising details here is that it's TAA compliant.
Ah, yes.
For our listeners who might not deal with, say, federal contracts, what does that compliance really tell us?
That TAA compliance is, it's a huge deal in the professional world. It basically means the product is made or substantially changed in the U.S. or a designated friendly country. It guarantees a certain level of supply chain security, which is absolutely essential for critical infrastructure monitoring.
Right, so no cheap imports where it really matters. And then let's talk hardware. It needs a dedicated 12-volt power supply, which is included.
And that detail tells you almost everything you need to know.
It's definitely not running on AA batteries for a year.
Not at all. That 12V1A power draw suggests there's something inside that needs a sustained, stable current, likely an electrochemical sensor that needs to be kept at a constant temperature for high-accuracy sampling.
And that stability is what allows for the precision in the alarm points.
Which brings us to the most critical part of this, the preset alarm points. This is the intelligence that defines what the detector is built for.
This is the key takeaway for you.
It is. The device has this graduated, tiered response based on concentration in parts per million and the duration of exposure. You see a very clear inverse relationship. The lower the concentration, the longer it'll wait to alert you.
Okay, so break that down for us. What's tier 1?
Tier 1 is for low long-term exposure. It alerts at 70 ppm, but only after it's been at that level for 60 to 240 minutes.
So it's looking for a chronic, simmering problem.
Exactly. Then Tier 2, for medium exposure, it jumps to 150 ppm.
And the alarm window.
It shrinks significantly, down to 10 to 50 minutes.
Wow, okay.
And then you have the immediate danger zone, 450 p.m.
And that has to trigger an alert within 4 to 15 minutes. But hold on a second. If 400 ppm is that life-threatening, why is there a window at all? Why up to 15 minutes? Why isn't it just instantaneous?
That is a fantastic question, and it really gets to the heart of reliability in these systems. That 4 to 15-minute window is for confirmation.
To prevent false alarms.
Precisely. It's balancing speed with certainty. The system needs to confirm that this isn't just a brief environmental spike like a truck idling nearby before it triggers what could be a massive building-wide emergency response.
I see. So the key metric here is the precision of that time concentration calculation. But this device isn't alone, right? It's part of a bigger ecosystem.
Exactly. It's just one piece of a much larger safety grid that NTI offers. This confirms that industrial safety is all about a multi-sensor approach.
Yeah, the source lists a few others just for context.
Right, you see a gas detector for things like methane or propane, that's around $420. Then a basic spot liquid detector for about $285. But then you get into the really specialized gear. For example, a hydrogen sulfide H2S detector is priced way up at $1,210.
Oh.
So this CO detector's position shows that while it's pro gear, the tech complexity and the price, it's tiered based on the specific danger of what's being monitored.
So the core value of this deep dive is really recognizing that this kind of safety technology is all about specific, time-sensitive PPM measurements. It's not binary.
Precisely. That tiered response tells the entire story of its professional application and, justifies the price difference.
And that leaves us with a final thought for you to consider. How much does that specialized compliance, that TA designation, actually impact the physical function of the device? Are we paying for a better sensor, or are we paying for a guaranteed secure supply chain? Or perhaps at this level, you just can't have one without the other.
Something to think about.